My name is Benny Kuriakose. So, I have a master's in conservation studies from the University of York. So, that's how I got into conservation. After I graduated from the College of Engineering, Trivandrum, I worked with Laurie Baker, who is a British-born architect working in Trivandrum. So, I worked with him for almost a year. I learned my basic lessons in architecture from him, and then I went to UK to do my masters, and I was practicing in South India. I've been involved in the design of new buildings and a lot of conservation projects. I was involved in an important project in around the outskirts of Chennai called the Chitra, where we transplanted traditional buildings from the four southern states. And so, tremendous experience I had when I transplanted the buildings and learned about a lot of the joinery materials, the different kinds of architecture across different parts of the South India. I was involved in Mussoories Heritage Project. Mussoories is a historic port where the Romans and the Greeks and Arabs and the Portuguese, a lot of these people came from all over the world. And because Kerala was famous for the pepper trade, it's part of the spice route, and the port disappeared in the 14th century. We don't know exactly. People say it is because of the floods, but the remains of the port or some of the evidences. I mean, there are three synagogues, there are some historic forts there. The oldest European monument, surviving European monument, is there, and the oldest mosque in India is in Mussoories. So we did the master plan for the Mussoories Heritage Project, and we are looking after the implementation of the Mussoories Heritage Project. As a practice, our office, we have we do about 50% of our projects is new buildings, and about 50% is the conservation of historic buildings. And so we are involved in all kinds of projects. So we design residences, we have done some hospitality projects, we are involved with design of some schools and some other institutions. We do master plans, and so we do A to Z in architecture, planning, conservation, and in historic sites there you need to design new buildings. That is also something which we do. We try to do buildings which go along with the historic buildings. Today I'm going to talk about timber. Timber is, I will say, a wonderful building material, and it is used since historic times. It's generally considered to be a perishable building material, but I would like to say that the timber, if properly taken care of, will last for a very long period of time. Timber has many properties. Each species of timber, the properties vary. There is no universal timber. There is no timber which can be used for all the purposes, because water is normally considered as a universal solvent. Similarly, I mean, timber, depending on the species, depending on the purpose, it varies. And for example, if you want to use for rafters or timber beams, the strength becomes the most important criteria. In tropical countries, teak is considered to be Tectona grandis, is the botanical name. It's considered to be a good species of timber. But there are other timber species which are 50% more stronger than teak. And so for rafters, that is more appropriate. And when it comes to furniture, for example, it is the grains which is important. Teak has beautiful grains, rosewood has beautiful grains, and the timber should be lightweight as well. You should be able to move one chair from one place to the other. So there are The criteria for selecting furniture is different. One of the traditional examples of usage of timber is the say bullock cart. Each part of the wheel, bullock cart wheel, is made out of different species of timber, because each timber has a particular property, and that is what becomes very important in the case of timber. And uh, timber is measured, I mean the strength, the utility of timber is measured in by various aspects. For example, teak is considered to be very expensive in India. The price is quite high. Of course, rosewood and ebony, etc. There are some timber species which are even more expensive than teak. Eucalyptus, the cost of eucalyptus is one tenth of that of teak, although there are many properties of eucalyptus as a timber is better than that of teak. For example, the modulus of elasticity, the bending and torsion, and the weight is density is much higher. And so many of these properties, although it is better than that of teak, the price is less because the dimension stability of teak is not there. As you make a furniture with eucalyptus, it bends, or even if you use it as a rafter, the tendency for the timber is to bend, and so as soon as it is cut. So there are so many properties which are required for each of the purposes, and there are not many timbers which can be used for all the purposes. And coming to the durability of timber, the general impression is that timber is not durable. But I will say that the timber will last for centuries. It is very durable. The only way timber can get decayed or destroyed is only by two things: either by insect attack. Insect can attack timber, like termites is, I mean, one of the things, or there are certain furniture beetles, and there are some bugs, etc., which comes and attack timber. So if the insect attack is not happening, then the timber is durable. The other way timber can decay is with fungal attack. I've seen buildings, even bamboo. Bamboo is not timber. Bamboo is considered to be a grass, one of the fastest growing grass in India, in southern India, and various northeastern parts and various parts of India. The poor people in the olden days, even the rich people, used to build with bamboo. Bamboo, even I've seen buildings with bamboo, which is more than where it is used as rafters and battens. It has lasted for more than 100 years. Old buildings I've seen. It is survived because it's not just not attacked by insects and fungal attack. So these two conditions are I mean, not happening, then the timber will last for a much longer period of time. The other impression about timber is that the fire resistance of timber is much less, which is not true. Especially the thicker pieces. For example, in a roof or anything, if the fire catches, it gets a black coating on top of it with the fire, but that coating protects the timber. So there are no casualties, or there are no collapse of the structure. But the structure will look very damaging. It's going to collapse with the blistering and all those things happening. It doesn't burn. I mean, the structure doesn't collapse. So, and even if, in fire resistance, even a panel door which is thick, there has to be a minimum thickness for the fire resistance. If there is a minimum thickness available, then the timber will last for, I mean, it will be quite resistant to fire. It is much fire resistant compared with, for example, steel loses its strength at 300 degrees centigrade. It doesn't have any strength, where timber can withstand at much higher temperatures. So again, it's people think that timber doesn't have fire resistance. Um, and in each of the location, each of the place, depending on the location, there are different kinds of scale which is used. There are traditional knowledge, and because it was a material which is used in historic buildings. For example, in Kerala, uh, we had a different scale. For example, one angulam is approximately 3 centimeters, and 24 angulams is equal to one coal, and one coal is approximately 72 centimeters. I mean, in the olden days, there were no meters or feet or any of those things, and there are these carpenter used a scale which is approximately 72 centimeter. Why I'm saying it is approximately 72 centimeter is because the carpenters used to make the scale. There was no standard dimension or standard coal which you can buy from the market. So each carpenter used to make 3 centimeters. So the 3 centimeters used to be approximately 3 fingers, and that's the bit they use for making the that is the scale which they use. And there are certain ancient Sanskrit texts, I mean, ancient texts which are written. Many of them are translated into English and regional languages. For residential buildings, there was a text called Manishyale Chandrika. And for temple building, there was a text called Tantra Samuchaya. And these texts deal with the selection of the plot, the qualification of the craftsman, the selection of trees, how do you select the soil test that should be conducted, all these things. And but you can't read these texts and practice traditional buildings or do timber roofs. These are meant for the practitioners. And if you look at the buildings in Kerala, the carpenter is the main decision maker. He is the designer of the building. Whereas in many of the European buildings, traditionally masons used to be the main decision maker or the architect. And but in timber buildings, I mean, it's the carpenter because he decides the dimension of the rooms and the size of the house, etc. And traditionally, all these roofs were made completely prefabricated, and they did not. I mean, they made the roof at the floor, and they assemble the roof in 3 or 4 days, depending on the size of the roof. So what I would like to say is it's fully prefabricated, and there are no iron nails or anything which is used for making these roofs. And some of the buildings had very large spans. Many of the, for example, the Kutambalams is nothing. Many of the temples had, not most of the temples, a small number of temples used to, I mean, which has survived, used to have performance spaces. This is where the traditional Kutha was performed, or Kuriatam or Kadagali, many of these things were performed. So these things used to have a slightly larger span, and these, I mean, so the traditional, but they used to have columns in the middle. But there was a science behind it, and the carpenters, although they did not know any trigonometry, they used to fabricate the roof by making it at the ground level. They did not have any drawings made for this. They scale up the building depending on using the traditional coal as the dimension. And one of the things what you find in these traditional historic buildings in Kerala is that all the structures above the wall plate, and it was called arudam in the local, in the vernacular language, anything the roof which is above the arudam is subsidiary. Anything which comes below it, because there are buildings where the walls were also made with timber, anything below the wall plate or arudam is also subsidiary. The main thing was the arudam. They start with the dimension of the arudam, and it's not measured in feet, as I said earlier. It is measured in coal, for example, and they never used to measure it length and breadth. They used to tell the perimeter. For example, one of the auspicious dimensions was 16 coal and 8 angulams, which is there. There is 29 coal and 16 angulam. That was another auspicious dimension. As I said earlier, it is the perimeter which is very, very important. This traditional know-how is not there with many of the modern, I mean, with the modern engineers and architects have not learned much about timber. They might have learned one chapter about timber in their construction textbooks. They are not exposed to that learning of timber as a building material, and that is one of the sad facts. Timber joinery is very important, and there are uh, the joinery, for example, the joinery which used in Kerala and Tamil Nadu, two neighboring states in South India, is different. Even within Kerala, you just travel 100 kilometers, the joinery will be very different. The way the roof is made, as I told earlier, there are no iron nails in making the timber joineries of in joining the wall plate or joining the rafters, or the way the rafter and the junction of the rafter with the wall plate. They use wedges, and that's how they do the thing. And I'm not going to work or show the details about the joinery. I've just shown some sketches. It varies. There are various ways of joining, connecting the rafter with the wall plate itself. And one of the simple things I would like to tell is, say for example, in the very olden days, uh, all the rafters used to get crowded at the top. uh, this is when you make a bamboo roof. You don't have the hip rafters and jack rafters and etc. All the rafters get crowded at the top. And so when they might have, in the olden days, very thousand years ago, they would have made roofs out of bamboo and they would have followed the same thing. And when they switched over to timber, they used the same kind of joinery and the method. So there are still a lot of buildings in Kerala. Here, mostly, if you see such a building, you can more or less assume that the building is 150, 200 years old, like what I'm showing it in the slide. All the rafters are getting crowded at the top. These rafters are not made now. Now, what you see is the image which is there, where the you have the hip rafters and jack rafters, uh, and the principal rafter, etc. The principles is more or less the same. The traditional way of making uses more timber, whereas the conventional one doesn't use that much amount of timber. Now, coming to the insect attack, there are various insects. For example, if I just want to talk about termite attack, termite itself, there are 2000 varieties of termites, and each attacks in a different way. There are flying varieties of termite. For example, the one which is very commonly found, I mean, that some of the other varieties are also commonly found. Uh, One of the things is the ground earth termite. And the ground earth termites means the queen of the termite lives in the ground, and the termites might attack the timber in the first floor or ground floor. It can attack even in a modern building. It can attack wardrobe in the fourth floor, even 10th floor also. The thing is very simple. These termites always need to keep its contact with the ground. Without keeping its contact with the ground, it cannot survive. In traditional buildings, the walls were inside of the walls there were many voids, or the walls were built with lime mortar or with earth, so there was gaps, and through the joints these termites will start attacking the timber in the roof. But in the modern buildings with the concrete bells and the concrete beams and things, the chances of attack is much less because it doesn't bore through concrete if there are no voids. But the ground earth termites attack. I've seen many cases where the ground earth termites attack timber in the third floor or fourth floor. That happens because they come through the electrical pipes or some plumbing pipes where the water is not coming. And if they attack the timber, these kind of termites don't like light. So where they are to come out, when their path is obstructed, they have to cover their path with mud, and that is what you normally see when the ground earth termites attack. Similarly, there are other varieties. Each termites work in a particular way. So when you give the treatment of the ground through pest control measures, you are treating it against only one or two types of termites. There are other types of termites which will attack the timber. Traditionally, and what I'm showing is that means there are timber columns where a stone base is used. The advantage of the stone base is that Termites will not be able to attack the timber column in such a case. I'm showing two. In the one of the left hand side bottom, what you see is the column where the timber base is used. So that can be attacked by termites. So a physical barrier is good enough. You need not have a chemical barrier, and it is there. So when the termite attacks comes in traditional historical buildings, you will have to treat it. I mean, in many of the cases, if the attack is severe, you have to use chemicals, and there are various different chemicals available in the market. They are all poisonous chemicals, but there is no other way except to use these chemicals. I will just go into the fungal attack or fungi attack. Fungal attack will happen only when there is moisture, when the timber is wet, because I mean you have in the rainy season in tropical climate what you if you close a room for 3 days, then when you open the room there is a smell, uh, and there is no ventilation, then the fungal attack will come. When the fungal attack comes, is when the moisture is there, the roof rafters get wet, and there's a constant rain. So that is where the damage of the timber rafters of timber beams. And it normally in a historic building, it is the valleys which get attacked first because there might be some kind of leakage in the valleys. That's where the problem comes. And I'm showing a picture of a timber bridge in sea in one of them. What happens, the top portion, you can see from this, the top portion is not damaged because it is completely dry. Fungal attack will not happen in normal. Fungal attack will never come to furniture because the moisture content is much less. It will be 12% or 15%. When a timber is freshly cut, the moisture content is 65%. So that is why you do the seasoning of timber. You dry the timber, and it becomes I mean, so what happens when you do the seasoning? The moisture content, which was 65%, comes down to say 15%. The fungal attack can happen only when the moisture content is much higher. Say if it reaches 25% or 30%, then the fungal attack will happen. So keeping a building dry will make sure that the timber is durable, and the timber which is fully immersed in water, like what you see it in the picture, also will not get damaged much because there is no oxygen when the timber is fully immersed. For fungal attack to take place, there has to be oxygen. So what you see the damage when you have a timber column or a timber bridge in water, it is the junction where the water level changes. That's the part which gets damaged. So which is very, very clear. And this picture which says the timber which above which is dry is completely safe. The timber which is fully immersed in waterlogged wood, is also safe because there is very little oxygen or no oxygen. It is that the junction between the water and the air is which is getting damaged, because there is adequate moisture as well as there is enough oxygen for the timber decaying fungi to function. uh, so, one of the basic principles when you look at historic buildings is to make the building dry. Another important condition is to have a good ventilation in the roof as well as most of the areas. These were very well taken care of in many of the historic buildings, but due to some intervention in the building, those ventilation might have been blocked. Suppose you add a false ceiling or you block the ventilation to keep the building warm, then the timber, when the roof leakage comes in, the timber is liable to be get attacked by fungi. Then the only two ways by which these two buildings by which timber gets affected is through the insect attack and the fungi attack. One of the very important things in timber buildings is the craftsmanship, and this knowledge has been transferred from generation to generation. In Kerala, for example, all these about 100 years ago, or more than a little bit more than that, most of the buildings of the middle class and the upper middle class, etc., were built with timber also as walls. Not only the timber roof, the walls were also made with timber. And you can see the skill of the local blacksmiths in making the locks, and the carpenters used to make the carvings, timber carvings, and they used to make perfect buildings. The quality of the workmanship was very, very high in these traditional buildings. When we had got involved in many of the restoration of the buildings, we tried to keep the maximum of the original as possible. Minimum replacement is the policy that we follow. Uh, and Many of the timber buildings will have blacksmith's work as well. For example, in the photograph which I'm showing, the hinges are made by the blacksmiths, and they are made by hand in a local blacksmith's workshop. And when you make it in a machine, or when you make it in a this thing, you will not have the touch of the hands in these things. And we take a effort to make sure that the craftsmanship is maintained, and the local blacksmiths are employed to make the hinges, not using these modern hinges. So this is one case where we had to replace the hinges. This photograph shows, and the roof work is very perfect. It's very difficult to find any drawbacks of many of the roofs. uh, Very little inaccuracy is found. And that craftsmanship is still alive, even with many of the youngsters which we see at the site. And this picture shows a timber column where some part had to be replaced. How they have tried to cut out the piece and replace it with another piece. In many some cases, they even try to match the grains or the pieces which they try to replace as part of the project. And for example, in this, I mean, the minimum parts, minimum material, maximum of the original material has to be replaced. You see the skill of the craftsman in this photograph. At the end of the rafter, how they have joined to an existing rafter with such fine workmanship has to be seen. Um, uh, the normal things that we follow when to replace a member. Uh, the guidelines that I give it to the sites is that unless more than 50% is damaged, do not replace timber members. So if some small, because most of these timber members are highly oversized, because traditionally they did not know the strength of a column or a strength of a beam. So what I found is that, or a rafter, even if a major part of it is damaged, still it is able to carry the function or carry out the purpose. So this is the guideline. And one of the other principles, which is a kind of a convention in the conservation of historic buildings, is that normally the timber carvings are never, you don't try to replace a timber carving in the buildings. That you try to avoid it as much as possible. um, is one of the things. There are some conservation architects who try to replace the timber. When the carving has to be replaced, they give a geometric pattern. Or whereas, I mean, no, nobody, I mean, it's because that carving is done by a craftsman or and that has to be valued. And when you make a new carving, it's a new carving, not the original carving. So even if something is slightly damaged, or something is deteriorated or decayed a little bit, it's better to consolidate it and keep the maximum of the original material as possible. And I'm just showing an example of a synagogue where we had to work. This is an older photograph of the synagogue taken in the 1950s and 60s. Synagogue, the old Torah, the Torah, or which is the Old Testament of the or the Bible of the Jews, is kept in the ark or the heikel. I mean, they call it an ark or a heikel. What is so? It's similar to the altar in churches, highly decorative. So what you see, this is the 1950s or 60s photograph with the chandeliers, and the Heikel or the original ark was dismantled and taken to Israel when the Jews went back to Israel. So, what this is the original synagogue Heikel, part of the top portion of the original Heikel, which was kept in the Parur Synagogue, which is in Kerala, part of the Musaris Heritage Project. And I mean, this is the photograph of the synagogue when I visited the synagogue first. You know, the original timber carving Heikel is missing, and what you see is some bathroom tiles in its place. So this is what we took, looked at the photographs, made the accurate drawings as part of the things. And you know, there are a lot of details. There are some Hebrew letters in it. So looking at the photographs, we couldn't make a trip to Israel. One of the architects in my office made the drawings, and we took the drawings to Amin, and we employed craftsmen to do, because we thought that the Heikel, of course, it's part of the Jewish heritage, which sitting in the Jerusalem Museum, but it's part of Kerala's heritage. It's part of the history heritage of India. So we decided to recreate it, looking at the photographs, because it's a pride of Kerala that this Heikel has to be restored or recreated as part of the. Normally, such a thing is not done because it's a new Heikel, new carving done by new craftsmen using new timber, and that's what. So we engaged craftsmen who started making it. Now, if anybody visit the synagogue now, they can see the new replica of the old Heikel there. And without this Heikel, the synagogue is incomplete. We have now converted the synagogue into a museum because most of the Jews had gone back to Israel, and this synagogue tells the history of the Jews and their relationship with Kerala is being portrayed in this museum. And now to conclude, I would like to tell how the sustainability aspects of timber. Timber is the most sustainable building material. It's very it can be easily be recycled. It can be easily be grown, and so that is why now, you know, the climate change is happening, global warming is happening, the temperature is going up, the carbon dioxide or the carbon emissions are on the higher side, the carbon dioxide in the atmosphere has gone up, and as a result the whole earth is warming up. And as a result, we have a lot of disaster. The number of disasters have gone up. There are floods are frequent, hurricanes are frequent, cyclones are frequent. A lot of changes are happening in the surface, and they say the sea level will rise. The cities will look very different 30 years or 50 years from now. Most of the cause, I mean, they say the I mean, there are predictions that the sea level will rise by 1 meter. There are some people who say it's 2 meters. If the sea level rises by 2 meters, 85% of Venice will be underwater. So it's a very kind of serious situation. And a lot of measures are being taken to reduce the effect of climate change. A lot of measures are being taken to adapt to the climate change. And yeah, in this case, trees play a major role. That we can use timber, which are sourced from plantations. I am against timber being used by cutting down the natural forest or the virgin forest. But if timber can be sourced from plantations, then timber can be used in the buildings. We can grow trees again, because trees is the only thing which can convert carbon dioxide into oxygen. So you have more trees, more. There are a lot of wastelands available across the world, within India and many other countries. A lot of areas are vacant. So if we can grow some trees, then these trees will convert the carbon dioxide. So slowly, I mean, I mean, you have to go in huge areas to reverse the climate change fully, but at least we will be able to arrest the climate change to a great extent if we can grow more trees. It's a very, very slow process. Of course, it's a debatable subject. as part of it. So if you're not cutting down the natural forest, if you are taking the plantations, and from the plantations you use the teak for the timber, then it is very sustainable. And that is why the timber is considered to be the very sustainable building materials. As I said, um, so the advantage of using timber in buildings, the carbon dioxide is never emitted. Carbon dioxide is kept in the timber, which is used for making buildings. And but if the timber is allowed to decay or timber is used as a firewood, then the carbon dioxide is emitted. So there is so the carbon emissions. So if the architects start using more and more timber in buildings, then slowly this can be reversed, and that is why the timber is considered to be the most sustainable building material. So timber has a tremendous role even in the contemporary buildings as a thing. Whereas many of the modern materials like aluminum is highly energy intensive. Even steel uses a lot of energy in the production of steel. But timber can be used. Timber can reverse the climate change, and the carbon gets locked in timber. So I consider timber to be a very sustainable building material, and there are more than 55 million families in India without a house, and timber could be the future building material to solve the problem of the roofless millions across the world. I'm not talking about teak being used. I'm talking about so many other species which can be used. Of course, the cross laminated timber is being used across the world. There are many projects where they use the CLT or the cross laminated timber, and in Europe, etc., it's becoming a trend now. But there are many architects who work with the CLT in their buildings. But in the tropical countries, it's still a distant dream. And what we need at present is to use the knowledge of the traditional timber knowledge, timber joinery, the way the timber is being used, beautiful buildings our ancestors have created with timber as a building material. So we have to look at a blending of the traditions and the modernity, and that is what is needed for the future.